So here is another question on thermal expansion of materials. It is given that on heating a glass block of volume 10,000 centimeter cube from 25 degrees Celsius to 40 degrees Celsius, its volume increases by 4 centimeter cube. Calculate the coefficient of linear expansion of the glass block. Okay, so this is a very interesting question because the information which is given, it is based on volumetric expansion, volume expansion, but it is asked to calculate the linear expansion coefficient. So let us try to solve it. So it is given. First, let us write all the information which is given. So for the glass block, the initial volume V0, okay, this is the initial volume, that is equal to 10,000 centimeter cube. Okay, the initial temperature, that is equal to 25 degree Celsius. The increase in volume or change in volume, that is equal to 4 centimeter cube, and the final temperature, that is equal to 40 degree Celsius. Now we know for volumetric expansion, the change in volume is equal to the coefficient of volume expansion gamma, the initial volume V0, and the change in temperature or the increase in temperature delta T. So here delta T is final minus initial temperature, which is equal to 40 minus 25, which is equal to 15 degrees Celsius. So here we'll simply put the values. Here our objective is to calculate the coefficient of volume expansion gamma. So gamma is equal to delta V by V0 delta T. Okay, so it is equal to 4 centimeter cube, the increase in volume, by initial volume, which is equal to 10,000 centimeter cube, into the increase in temperature, that is equal to 15. So it is coming around 26.67 into 10 to the power minus 6, okay, per degree Celsius. This is the coefficient of volume expansion. Now if you remember, we derived a relationship between the various thermal expansion coefficients: linear expansion, surface expansion, and volume expansion, alpha, beta, and gamma. So there we derived that the coefficient of volume expansion is equal to 3 times the coefficient of linear expansion. Gamma is equal to 3 alpha. Okay, similarly beta is equal to 2 alpha. So here we'll be using this relationship. So gamma is equal to 3 alpha, that implies alpha is equal to gamma by 3. Okay, gamma by 3. So it will be equal to 26.67 into 10 to the power minus 6 by 3. So it is coming around 8.89 into 10 to the power minus 6 degrees Celsius. This is the coefficient of linear expansion of the glass block. Okay, first we used the basic concept of volumetric expansion and that formula to determine the coefficient of volume expansion, and then we use the interconversion formula to convert one expansion coefficient to the other, the relationship between them, to get the coefficient of linear expansion. Okay, so this is this. So here is another question on thermal expansion of solids. So it is given that a sheet of brass is 40 centimeter long and 80 centimeter wide at 0 degrees Celsius. If the surface area at 100 degrees Celsius is 320.1 centimeters square, find the coefficient of linear expansion of the sheet of brass. Again, the information, the data is based on surface expansion, but what is asked in the question is to determine the linear expansion coefficient of the sheet of brass. So first let us write all the data which is related to the sheet which is given for the brass sheet. Okay, the initial length, the dimension is 40 centimeter and initial width is equal to 80 centimeter. So the initial area, length to width, that is equal to 320 centimeter square, the initial surface area of the brass sheet. Initial temperature is equal to 0 degree Celsius. Now the final temperature is 100 degrees Celsius and the final surface area is equal to 320.1 centimeters square. Here the change in temperature, Tf minus T0, final minus initial temperature, that is equal to 100 minus 0, which is equal to 100 degrees Celsius, and the change in surface area, delta S, is equal to SF minus S0, final surface area minus initial surface area, that is 320.1 minus 320, that is 0.1 centimeter square. Now if we remember, we discussed the surface expansion. In that, the change in surface area of a solid, a material, is equal to the surface expansion coefficient beta multiplied with the initial surface area and the change in temperature. So here our objective is to determine the surface expansion coefficient beta. So that implies beta is equal to delta S by S0 delta T. Okay, so here change in surface area is equal to 0.1, initial surface area is equal to 320, and the change in temperature delta T is equal to 100. So the surface expansion coefficient beta, it is coming around it's coming around 31.25 into 10 to the power minus 7 per degree Celsius. Okay, it is in degree Celsius, yes. So here we have calculated the surface expansion coefficient, but it is asked to determine the linear expansion coefficient. So here we have to use the relationship between various expansion coefficients. We know beta is equal to 2 alpha, that is surface expansion coefficient is 2 times the linear expansion coefficient. That implies alpha is equal to beta by 2, which is equal to 31.25 into 10 to the power minus 7 by 2, which is equal to 15.625 into 10 to the power minus 7 degrees Celsius. This is the linear expansion coefficient of the sheet of brass. Okay, so this is the thing. First, we utilize the surface expansion formula to determine the surface expansion coefficient beta. Okay, and then we use this relationship between alpha and beta to determine alpha, which is equal to beta by 2, which is equal to this much. Okay,